Hello, so this video is going to be on part A of question 1 of the Maths 2018 paper. And for this question, we have to find the area which is bounded by these two lines and the x-axis. So first of all, I think it's useful for us to draw a little diagram so that we know exactly what area we're trying to find. And this is the diagram that I prepared. So these two lines are the lines that they give us. And we want to find the area between these two and the x-axis. And so that's just this area that I'm shading in here. Alright, so I reckon it's going to be easier to find the area underneath this y equals root x curve up to this point where it crosses the y equals x minus 2 curve, and then take off this triangle. So we know that this point right here is going to be 2, and we'll also need to work out what this point is. Right, so to find this point, we do the standard thing of putting the equations of these two lines equal to each other. So we have root x equals x minus 2. And now if we square both sides, and we expand this bracket out on the right-hand side, we get this quadratic. So now I'm just going to take x off both sides. So now we have this quadratic we can solve. And if we take a look, that's actually equal to x minus 4 times x minus 1. So we know that our values of x are 4 and 1. Right, well, if x is either 4 or 1, we can see that it's going to be greater than 2. So the point that we're interested in must be 4. And the x equals 1 is actually, if we had drawn the other branch of the square root, x equals 1 would have been this root here. Right, so now if I want to find the area under the y equals root x curve up to 4, we're going to have to do an integral. So if we integrate square root of x between 0 and 4, we get here. So of course this 0 doesn't matter, and if I rewrite the 4 to the power of 3 over 2, as 4 to the half cubed, then it's a bit easier to see that that's equal to 2/3 times 2 cubed, which is 2/3 times 8, or in other words, 16 over 3. Alright, so now we've worked out this whole area here, so we need to find the area of this triangle and take it off. So for this area of this triangle, we see we've gone along 2, so its base has length 2. And because the slope of this line is just equal to 1, that means we've also gone up 2, so its height is also 2. So if we use this formula for the area of a triangle, we have a half times base times height, which is just half times 2, which is of course just 2. So now for this red shaded region, we need to take this area 2 off of the area that we found before. So we get 16 over 3 minus 2, which is equal to 10 over 3, and of the options that they give you, that is option D.